The derivative of secant of x is secant of x times tangent of x. There you go. Next one, cosine of x. What's the derivative?
Negative sine of x.
Negative sine of x. Good job. Next one, this is a limit. What's the limit as x approaches infinity of sine of x over x?
0.
What is the derivative of cotangent of x?
Negative cosecant squared of x.
Negative cosecant squared of x. Good job. What about the derivative of cosecant of x?
Negative cosecant x times cotangent.
Yeah, negative cosecant of x times cotangent of x. Good job. All right, what is the limit as x approaches infinity of cosine of x over x?
0.
What is the limit as x approaches 0 of sin of x over x?
1.
What is the derivative of y equals sin of x?
Cosine of x.
What is the derivative of tangent of x?
Secant squared of x.
Secant squared of x. Good job. Nice. And that's the end. Now we are going to be adding a lot more of these shortcuts to our flashcards. And if you wait until right before the test to memorize all of this, it's just too much information. So let's memorize this in pieces as we progress through this course. So let's go to our rental verification. Jillian.
You just have to properly do the chain rule.
Yes, for your rent. If you properly do the chain rule, then you do not pay your rent this month. The assignment that is due today is 4.3. 4.3 is on implicit differentiation. Implicit differentiation. What does this word differentiation mean? Yeah, taking the derivative. If you differentiate something, you are taking the derivative. And then implicit, well, everything that we've done so far is explicit differentiation. If I have something like, this is explicit. Explicit. If I have y equals 2x squared plus 4x minus 6, and we take the derivative of this explicitly. What does this explicit mean? Isn't that like directly?
Yeah.
So if I do something directly, I do something explicitly, then this becomes what?
4x.
Y prime.
Y prime equals
4x plus 4. What's the derivative of negative 6?
0.
0. So there we go. Now, what if I rewrote this and we're going to do the same problem again, and we're going to do this implicitly. So now we're going to do this implicitly. Implicitly. So what if I have, I don't know, 6 minus 4x plus y equals 2x squared. Bentley. Is this the same thing? Did I write this equation? I mean, does it represent the same equation?
Yes.
Yeah, just in a different order, but it means it represents the same graph. Now we're going to do this implicitly. Which means if explicit means directly, what does implicit mean?
Indirectly.
Yeah, indirectly. We're solving, we're taking the derivative indirectly. Okay, let's do this starting from the left-hand side. What does this become? 0. What does this become?
-4.
-4. What does this become?
Y prime.
Y prime. And what does this become?
4x.
That becomes 4x. Is this the same thing as this?
Yes.
Sure. Now, since we solved for it implicitly, then if we wanted to still solve for the derivative with respect to x, we might want to rewrite it by adding a 4 to both sides so that we end up with an equation that is more explicit instead of implicit. So this is the important part that students, when we talk about implicit differentiation, this is the part that tricks students. When you take the derivative of y, we are still taking the derivative of y with respect to x. So when we take the derivative of y, we need to remember what?
Y prime.
Y prime. Okay. So what if I had something, let's try something like this. Here's my next example. I have y squared equals x to the power of 3 plus 4. Actually, I want to rewrite this. I'm going to make this to the power of 3. Y to the power of 3 equals 4x squared plus 5x. And the directions are find, I want to differentiate or I want to find the derivative. So find y prime. Can we do this explicitly? Can we solve for y prime directly?
No.
We can't? We can't do some type of algebra to get the y by itself. Okay, what would we have to do?
We have to take the cube root of both sides.
Take the cube root of both sides. Right now, we're not doing any calculus. I'm just rewriting this. The inverse of cubed is a cube root. A cubed root. So how would I find the derivative of this?
Well, we'll be just rewrite it.
Okay,
This is the
question, yes.
I was wondering if you should put like a plus or minus.
So that's a good question. Do we do plus or minus? Now, let's look at, so here's the question. Plus or minus, question mark. Now, if I have x squared plus 25, x squared equals 25. X squared equals 25. Okay, now can you think of what x could be where it would equal 25 on this, on the left-hand side? Yeah, if x is 5, then 5 squared, 5 times 5 gives me 25. And when x is -5, then -5 times -5 is a positive 25. So if I'm going to take the square root of something, then we better remember plus or minus, so that we'd have x equals the square root of 25 plus or minus, so that would give us plus or minus 5. But let's look at cubed. Let's look at a cubed root. What if I have something like this? I have x cubed equals 8. Can you think of what x is that will give me an 8 over here? What about a -2? Yeah. So the rule is, okay, now the rule is if we're going to take any even root, then we have to remember plus or minus. If it's an odd root, then you don't do plus or minus. So Kana, why do I not do plus or minus here? It's an odd root. Yep, correct. Okay, so we're back to here. We are solving this explicitly, directly. So now what? How do I find the derivative of this?
well, that's chain rule.
Yeah, this is the chain rule. So we take, oh, you wanted to rewrite this, right?
Yeah.
You wanted to rewrite this as 4x squared plus 5x all to the power of
1/3.
1/3. So when we take the derivative of this, that's going to give us
1/3
1/3
times 4x squared plus
times
5x,
4x squared plus 5x, okay?
power of -2/3.
to the power of, yeah, because we have to subtract 1. So that gives us negative 2/3 times the derivative of the inside function, right? Which is 8x plus 5. And we're done. And we're done. Now I want to do this. The main idea today is solving implicitly. So I want to solve for this without solving for y first. So I'm going to go back up here, going to copy the same problem. Now we're going to solve this implicitly. Any suggestions? How would we find the derivative of this over on the left-hand side? 3y prime squared. Isn't this the chain rule? Because what's our rule? This is the thing that trips students up. This is the part that trips students up right here. When you take the derivative of y, you get y prime. This is the chain rule. I'm taking the derivative, not of with respect to y, but with respect to x. So this is the chain rule. This is 3y to the power of 2, I agree with you, times y prime. This is the chain rule. And then it equals what? It gives me 8x plus 5. If we solve for this, will it give us this? If we solve for the derivative of y? Okay, so what do I do? How do I get y prime by itself?
3y squared.
Yeah, I need to divide by that. Yep. And so that's going to give me y prime equals 8x plus 5 over 3y squared.
And now you put in y.
Nice. We need to know what y is. We need to know what y is here. And we have y. We've already found y up here. We said y was this mass right here. So we're going to plug that in. I'm going to zoom out. I don't know if this is going to be too small. So that's going to give me, I'm going to substitute. I'm substituting this value right here of y back into here. So I have y prime equals 8x plus 5 over 3 times the cubed root of 4x squared plus 5x all squared. Is that the same as this? Yeah. So the 8x plus 5 goes in the numerator. What happens to this to the power of negative 2/3? What happens to this piece here? What do we do? What's our negative exponent rule? Move it to the denominator. That becomes this. And then 1/3, if you put 3, if we're multiplying by 3 in the denominator, that is 1/3. It's the same thing. We're getting the same thing. Well, why don't we always just rewrite using, why don't we always rewrite and then solve explicitly? Well, some problems are so confusing that it's just so much easier to do it this way. It is so much easier to do it this way. Okay, so the secret of doing this is when we take the derivative of y, we're still taking the derivative of y with respect to x. So when we take the derivative of y, what do we need to remember?
Times it by y prime.
Yeah, well, it becomes y prime, right? The derivative of y is y prime. The derivative of y is y prime. Now over here, this was the chain rule. The outside function times the derivative of the inside function. Are you confused? More problems? Jillian, how do you feel? All right, cool. All right, let's do a problem. What if I have x squared plus y squared equals 5 squared. Do you know what equation that is?
Circle.
It makes a circle. Yep, that makes a circle. In fact, it looks suspiciously like the Pythagorean theorem, doesn't it?
Yeah.
This is a squared plus b squared equals c squared. Yeah, it's the Pythagorean theorem. It will draw a circle with a radius of what? 5. Where is it centered? Where is it? Where is the circle centered?
The origin.
At the origin. Unless I did something to the x, that would be like x plus 5 squared. Let's do another something besides 5 because our radius is 5. How about 4 squared plus y squared equals 5 squared? Where's this circle centered? What kind of transformation takes place here?
Horizontal.
It's horizontal in what direction?
To the left.
To the left. We do the opposite in parentheses of what we expect. So that would be the funny business. Yep. So 1, 2, 3, 4. That's the center. Our radius is what?
5.
5. So we'd have a circle that looks more or less something like this. Yeah. Okay. So we have the circle. All that stuff doesn't matter. Just more of what's happening in our heads to understand what this equation looks like. Okay. We are going to solve this explicitly or implicitly? Yeah, so indirectly. So let's try to find the derivative of this. What is that?
2x.
Yeah, that's 2x. What about the derivative of this?
2y times y prime.
Yeah, 2y. This is the chain rule. We take the derivative of the outside function times the derivative of that inside function of y times y prime. And then that equals
0.
0. The derivative of a constant, which is 25, is 0. Now we still want to solve for y prime so that we know that just gives us guidance on how to solve for this. So as far as the derivative is concerned. So how do I solve for y? I'll subtract 2x from both sides. That gives me 2y times y prime equals negative 2x. And then divide 2y to both sides. That gives me y prime equals negative 2x over 2y. Now, it might seem like before I said, well, let's solve for y to plug it into here. I actually don't care about that. I was just trying to show that solving implicitly gave us the same answer as solving explicitly. That was the whole point of doing that. I don't want you to solve for y. I just want you to stop here. Just stay here.
Okay, so we just stop there.
Yeah, yeah. Now why do we have an x and a y? If I want to find, what does this mean? What does this mean? What does the derivative of y mean? Let's not lose track. It means slope. Now it says here that I need to find, and it's a slope with respect to what? It's a slope with respect to what? An x and a y. I need an x and a y. Why do I need an x and a y? Why do I need an x and a y?
You need an x and a y to have a slope.
For any x value, how many slopes do I have? 2. Where x is 2, I have a slope here. Here's my tangent line there. Here's my tangent line here. I have 2 slopes. So I need an x and a y to identify which slope I'm talking about. All right. So what is the slope? I want to know in this case, what is the slope? What is the slope at 4, 3? What is the slope at 4, 3? Is it going to be a positive or negative slope?
Simplify that equation.
I had 1, 2, 3, 4, and then 3 up. What's the slope going to be, positive or negative?
Negative.
It's going to be a negative slope. Yes, sir.
Couldn't we simplify that equation
Yes, to what?
to negative x over y?
Yeah,
Because we have no point in keeping the twos, it just adds more.
I agree with you. 2 divided by 2 is 1. I agree with you. All right, so what is the slope?
4/3.
Yeah. My slope is, my slope at that point, I'll just write m. Usually we use the letter m to represent our slope. It's going to be -4/3. What's that?
That's an easy slope to calculate.
Yeah. Just plug in your x and your y value. Let's do another one. Oh, let's do an equation. Let's do the equation of the tangent line through 4.3. Let's do the equation of the tangent line. We really need to get used to this. This is an idea. This really is a secondary math 1 idea, finding the equation of a tangent line. That's linear. So I want to find the equation. Is this too small? Not too small. Find the equation of a tangent line through 4.3. Mariah, did you get it? If it's an equation of a tangent line, we're going to use what equation? What's our generic equation for a tangent line? Yeah, we're just going to use y equals mx plus b. What does m represent? Yeah. Do we know what the slope is at 4.3? What is it? Yeah, we have -4/3 x plus b all equals y. What are we missing to finish our equation? We don't know what the b is. How do we find b? Yeah, just plug these in. We have an x and a y. What's my x? And my y? So I have 3 equals -4/3 times 4 plus b. How do we solve for this? How do we solve for b? Mariah. This here? Okay, to get what? Do we add these? We multiply them. Yep, to get what? Yeah, we have a fraction divided by a fraction multiplied by a fraction. Yeah. 16/3 plus b. Now what? And when we add fractions, we need to do what? Yeah, so I'm going to multiply by 1 in the form of 3/3. So that gives me 9/3. Does that look right? And then we're going to add the 16/3 to both sides equals b. So what does b equal? 25/3. So my equation then is y equals negative 4/3 x plus 25/3. Is everybody good with that? Should we Desmos it? Should we Desmos it? I think we should Desmos it. Thomas, you have a question?
Well, it's not quite a question, more of a suggestion. So there's another type of equation that I find much more usable for this. It's point slope form, isn't it?
Oh, yeah.
Yeah, you can just plug it in.
Yeah. Yeah, point slope form. Yeah, so this is what Thomas is suggesting. He's saying, why not use this equation point slope form, where we have y minus y subset 1 equals m times x minus x subset 1. We know what our xy values are. We know what our slope is. So why do we even have to do any math? Just plug and chug. So we have y minus 3 equals negative 4/3 times x minus 4. Thomas, are you okay with that?
Yeah.
Yeah, that's a legitimate equation. So the only problem is if that's not a multiple choice question, you'll have to rewrite it. Yeah, just distribute and then add the 3. Yeah. Yeah, I like point slope form. I think I like slope intercept more, but it doesn't matter. It's just personal preferences. So I'm going to Desmos this. Desmos is a verb. Well, it is now. Let me get rid of all of this. Our equation for our circle was x squared plus y squared equals 5 squared. We predicted that this was a circle centered at the origin with a radius of 5, and it is. Now we found our tangent line, and this tangent line is supposed to cross at, or it needs to go through 4, 3. And let's see, I think I have too many parentheses here. Let's see how we did. Our equation that we have. What should we just use Thomas's? Since I can't seem to scroll down any further. I'll just use Thomas's. Move Mr. Hall over here. Y minus 3 equals negative 4/3 times x minus 4. How did we do?
Yeah.
Nice. Cool. We've had that.
Mr. Hall,
Yes.
so would a circle be considered a function?
No.
Oh,
But it's still a graph,
oh,
right? It is not, a circle is not a function, but it is a graph. So what's cool is that now we're learning how to find the derivative of all graphs. It doesn't have to be a function. So in fact, this is our next one that I want to do. The next one I want to do looks like this: x cubed plus y cubed minus 9xy equals 0. Oops, xy equals 0. Yeah. That's the one I want to do this time. And for most of the graph, it looks like if I knew the x value, that's enough. But not in here. Is knowing the x, if I know x is 1, is that enough information to find the slope?
No.
Because there's 2 slopes. When x is 1, there's 2 slopes. There's a different slope here at the bottom than up here. So that's the next one we're going to do. So I want to find, oops, not even dark enough. Zoom in. I want to find x cubed plus y cubed minus 9x. Find dy dx. 9xy equals 0. Explicit or implicit? What do you think I'm going to ask? Don't you think implicit would be so much easier? Otherwise, we have to find a way to get these y's together. Now, it's not impossible, but it just means more work. Jillian, you were a little bit nervous at the beginning of class. How do you feel now?
Kind of just adding like one extra step.
Yeah. Yep. Carter, do you have it?
No,
Do you know how to do it?
not really.
Okay, we're going to do this piece by piece. The secret, Carter, is over here. This is the one that students get tripped up on the most, is understanding what to do when we have a y. Now, if you just have a y by itself, that's not too hard. But what if the y is inside of a function? Like, so are you okay with this part? If you see a y, just replace it with a y prime. But the problem is what if a y is inside of a function like here? So
And that's when you did the 3y squared times y prime, right?
yeah, isn't this the chain rule?
Yeah,
Yeah, just do the derivative. What is the chain rule, Carter?
that is.
The derivative of the outside function times,
The derivative of the inside function.
perfect, yes. So Carter, we're gonna do this one together. Okay, oops, where? I think I lost it. There it is. Okay. Carter, what about this piece here?
Oh, that would just be 3x times x, or would it just be 3x squared?
3x squared, yeah.
Yeah,
Now we don't have to, in this case, there is no inside function because we're taking the derivative with respect to x.
yeah.
All right, what about this one here?
And then it would be, is that a multiplication or addition sign?
Oh, this is addition.
Okay, and that'll be plus 3y squared times y prime
Nice.
minus, and does that seem, that's 9xy, right?
Time 9x times y, which reminds you of what? What should we do here? Isn't this, it's one of our tools that we need to remember. It's the product rule. We have this function here times this function here. So using the product rule. What is the product rule? If I have y equals f of x times g of x, then the product rule says that I rewrite this how? Our first function times the derivative of the second plus the second times the derivative of the first. So these are things we have to memorize. I suggest if you want to add these to your flashcards, that would be a good idea. So we have this is our first function, and this is our second function.
So we have, so then it would be negative, so minus
9x, right? That's our first function.
9x times y prime
Nice.
plus y minus 9
Yes.
added
Yeah.
0.
Yep.
Okay.
Yeah. Good work. Okay, now what? Well, we still need to solve for y prime.
Oh,
That's our next step, is solving for y prime. How do I solve for y prime? Bentley,
So first you minus 3x squared from both sides. And then you can minus,
could we do the same thing with this?
yes,
Okay, so we're going to subtract both of those so that our y primes are, any terms with y primes are isolated on one side. That should be our first step. So that's going to give me
3y squared times y prime minus 9xy prime is equal to negative 3x squared plus 9y.
everybody agree with that?
Then your next step is to factor y prime out of y prime minus 9x y prime.
Okay, we're factoring. Good job. So I have y prime times the quantity of 3y squared minus 9x. We'll leave the other side the same. Now what?
Then you divide 3y squared minus 9x from both sides.
Yeah, because that'll just give us 1 over here, and then times the y prime would just give us y prime by itself. So that's going to give me y prime equals negative 3x squared plus 9y over 3y squared minus 9x. Okay, now how do you feel about that? You're okay with it? Good. So we just need to know what a coordinates is. If we knew one of the coordinates, what one of the coordinates was, then we'd be able to find our tangent line and whatever else. In fact, find the slope at 4, 2. I want to find the slope at 4, 2. Thomas, did you watch the video?
Yes.
You did. I was suspicious of it because of some of your comments that you made. Could we have simplified that?
Yes.
Yes.
How could we have simplified it?
We could have removed.
It seems like, yeah, it seems like I could have factored out a 3 from the numerator and denominator, right? So we could have simplified it. I'm not super concerned about simplifying it. If it's not, if this was multiple choice, this probably wouldn't be one of your choices because it could have been simplified. However, if this is free response, stop there. Eileen, do you have the answer? Okay, so this is 4 is my x value and 2 is my y value. So don't, if I want to find the slope, don't I just plug those in? So when you say you don't know how to do this, do you mean you don't know how to do implicit differentiation? So it sounds like we need more repetition. And in fact, I was so concerned about how, I know that from teaching this in the past, I know this is a confusing topic. And so I found another video that I entered. I ended up putting that on Canvas as well. So if if you feel that Mr. Hall speaks gibberish and you don't understand how I'm explaining it, I suggest that you watch the videos that I have posted. So we are going to do a couple more examples like this, but I do want to know what the slope is. And to find the slope, this is my slope equation, right? That's what a derivative is. It's my slope equation. So I take my x and my y values, and I'm just going to plug those into my equation to find what my slope is. So that's going to give me, I have my m that represents my slope, -3 times x, which is 4 squared, plus 9 times y, which is 2, over 3 times y, which is 2 squared, minus 9 times x, which is 4. So order of operations, Eileen, what do I do first to solve for this? Okay, so I'm just going, order of operations says what, parentheses? There's nothing in parentheses to do. Okay, the exponent, so that's going to give me, that gives me -3 times 4 times 4 is 16, plus, well, now I already want to multiply. And then we have 3 times 4, and, oh, minus, what's that, 36? Now what? At 48. So -48 plus 18 over 12 minus 36. And then? So I get a -30 over 12 minus 36 is 24, -24. Yeah, and a negative divided by negative is a positive. And then they're both even. And so what, that would give me 15 over 12. Both are divisible by 3, it looks like. Three, 5. What? So they're both divisible by 3, right? How many times?
Then 5 over 4.
Yeah, 5 over 4. Yeah, looks good. What does this represent, Eileen? What is 5 over 4? The slope where? At 4.2. Yeah, the slope at 4.2 is, everybody's packing up like it's the end. Don't we still have another 10 minutes? Okay, let's continue on. Because we learn through repetition. We need lots of repetition. Let's do this one. So Eileen. Mr. Hall, just leave me alone. I really want to make sure that you understand this. I want to find dy dx for this 2y equals x squared plus sine of y. Now, I really want to emphasize the importance of this little piece up here. I'm going to go back, Bentley, in just a second. This is the confusing part for students. Eileen, what do we do when we're taking the derivative? What do we do with y? Yeah, when we take the derivative of y with respect to x, we make the y prime. Yeah. What do we do if y is inside of another function? We have to do the chain rule. We have to do the derivative of the outside function times the derivative of the inside function. Is that the confusing part here? Yeah, it's hard to see this as two functions. It's like, how is a function inside of another function? But remember, we're taking the derivative with respect to x. And this isn't x, it's y. So we have to think of it as the chain rule. So where were we? Down here at the bottom, maybe. I don't zoom out. There we go. So Eileen, we're going to take, we want to find dy dx, which means we want to find the derivative. So what do we do here? Do we have to do the chain rule? Yeah, in fact, if I wanted to solve for y, wouldn't I just divide by 2 to both sides and then I have y, and then finding the derivative of y is just y prime? So really, this is just, we can just take the derivative of all of this as one function, not two, not one function inside of another function. So this becomes what? It becomes 2 y prime. Yeah. What about this piece? Yeah, I agree with you. This piece? Yeah, this is going to be cosine of y. Times. So we took the derivative of the outside function times the derivative of the inside function. What's the derivative of y with respect to x? What did we do over here? What do we do when we take the derivative of y with respect to x? Yeah. So that becomes times y prime. Question?
So why is it like, why can you do that with y? Like the 2y equals that?
So why do we, so we're thinking of this. Whenever you see a y, we have to, because we're taking the derivative, not with respect to, we could take the derivative with respect to y, but then we have to do the chain rule with x's. And in fact, I could do that right now if you want me to. I'll just do this. And I'm going to take the derivative. So how about dx dy? That becomes 2, because the derivative of 2y is just 2. And then we have 2x x prime plus cosine of y. Because in this case, we're taking the derivative with respect to y and not x. But that's not what I asked you to find. I want you to take the derivative with respect to x. Think of the slope being different. If you're taking the derivative with respect to y and not x, your rise over run are different now. Your rise is going to be the difference between your x values, and the run will be the difference between your y values, right? Because you've just changed the graph to the side. You've rotated it. If you're solving for a slope, the slope with respect to y and not x. But I want to solve with respect to x, and so I need to think of this y value as, whenever I take the derivative of y, it has to be y prime. So over here, this is my outside function is sine of u, and my inside function is y. So we took the derivative of the outside function times the derivative of the inside function. Because we're taking the derivative not with respect to y, but with respect to x. All right, who was I picking on? Eileen? Eileen, how do I solve for this?
Divide by 2 to get y alone.
If we divide by 2, we have to divide everything by 2. That doesn't get this y prime alone, right?
No.
So what did we do before?
Divide by y prime to get that.
It wasn't the method that we used before to get all of the y primes together on one side, and anything that doesn't have y prime, we move to the other side. Wasn't that the method? Was it up here? Was that the method that we used right here? we wanted to, any terms that have y prime in them, I want to move to one side, and anything that doesn't have y prime, I move to the other side. Why is that helpful? Because let's look at the next line. What can we do on the next line? Yeah, we can factor out a y prime. That's why. So let's do that here. So we're not going to divide by 2. What are we going to do instead? Where this has a y prime and this has a y prime. Nice. So I have 2y prime minus cosine of y times y prime. Y prime is not in the function. It's out of the function. Y is a rotation. Y prime is a length. Okay. Oops. Okay. Now what? Oops. Now I'm missing this other piece over here, 2x. Okay. Now what? Y prime. It's not one. It's an apostrophe, right? So that gives me 2 minus cosine of y equals 2x. Is it negative 2x?
No. It's not.
I don't see it as a negative 2x. Okay, now what? Oh, you moved this to the side and then moved this over to the other side. Oh, I see. Yeah, you'll get the same answer. Okay, now what? This is times. My goal is to get y by itself, so I have y prime equals something. Nice. So I have y prime equals 2x over 2 minus cosine of y. There you go. Now I'm guessing, Jillian, that your answer was something like this. Y prime equals 2x over cosine y minus 2. Yeah. Yeah. Oh, negative 2x on top. Isn't it? If I multiply by a negative here, couldn't I just reverse those? Thomas.
You had to multiply negative to the top and bottom. If you wanted to reverse negative 1 over negative 1 to the things that there would end up with.
I see. If I multiply by, because I want to multiply, yeah, I want to, you're right. You're right. So this would be a negative and this is, yeah, you're right. Jillian, you're right. Thomas saved you. Okay, do we have enough time for one more? I don't know if we have enough time for one more. I see we have about 3 minutes. I'm guessing 3 minutes. I'm going to try. And why am I going to try? Because I feel like we need lots and lots of good repetition. So I want to find dy dx for x squared plus xy plus y squared equals 7. Gaia. What is the derivative of this? Correct. What is the derivative of this? Product rule. Product rule. This is times. All right. So yeah, x times y prime plus y times the derivative of this what's the product rule? First function times the derivative of the second plus the second times the derivative of the first, right? Okay, so we did, for the product rule, we did the first times the derivative of the second plus the second times the derivative of the first. What is the derivative of the first? What's the derivative of this? Isn't it just one? Yeah, it's just one. So I'm just gonna leave it the same. Now you have to take the derivative of y squared. Plus 2y times y prime, good, equals 0. Now we have to get all the, I want to find y prime equals something. How do I do that? Get the y primes on one side, good. So I have x times y prime plus 2y times y prime equals negative x, negative 2x minus y. Does that look right to you? Okay, now what? We can factor out a y prime. Y prime times x plus 2y equals negative 2x minus y. Now what? This is times. Yeah, so I have y prime equals negative 2x minus y over x plus 2y. Thomas, does that look right to you?
Yeah.
Okay. This is what is this tool called? Implicit differentiation.